Hi, this is Mr. Manley. In this video, I'm going to look at a three-variable linear system that has infinite solutions. If you've looked at my previous videos on three-variable linear systems, you know my method begins with numbering each of the equations, and then I'm going to choose two of the equations to combine. In this case, the first equation and the second equation I'm going to combine in order to eliminate the x term. So you should see that I'm going to be multiplying the second equation by 3 so that I can eliminate these common 3x's. So here I've got the equation number 1, and then here I've got equation number 2, but everything is multiplied by 3. Since the x terms are matching up, I'm going to subtract the second equation from the first equation, and that'll yield 9y plus 9z is equal to -9. Now, I have to use the third equation because I haven't used that yet, and I can combine it with either the first equation or the second equation. I like the idea of multiplying the second equation by 5 to eliminate the x term, so that's what I'll do. And here I've got the, what is this? This one is the second equation, and it's multiplied by 5, and this one is the third equation. And let me clean up my label here. My label should say that I'm working with equation 2 and 3. Now again, since the x's match, I'm going to subtract the second equation from the first equation. I'll get 0x, 18y minus 18z is equal to 18. Now I want to bring this equation down, and looking at the two equations, I'm seeing that if I multiply this by 2, I'll be able to eliminate the y term. So I'm going to do that, multiply this equation on the left by 2. So that'll give me -18y plus 18z equal to -18. And then I'm going to bring down this equation, 18y minus 18z equals 18. And then combining the equations, notice previously I was subtracting. If you look at the two others, I subtracted the second equation from the first equation. In this case, since my terms have opposite signs, I'm going to add the equations. So when I add the second equation and the first equation, I get 0 and 0. So 0y and 0z, and then I missed a sign here. This -9, when I multiply that by 2, I should have -18. So let's replace that -18. And when I do -18 plus 18, I get 0. 0 equals 0, and this is true. So that means that I have infinite solutions. And in the past, in algebra or algebra 2, that's where you would have finished up a problem like this, but you maybe didn't have three variables, maybe you did, but you would have finished up with infinite solutions. In this case, or in this class, in this course that I have watching this video, we are not going to stop there. We are going to express the infinite solutions in terms of another variable. How am I going to do that? I am going to really arbitrarily select y or z. Not entirely arbitrarily, because it's typical to select z. And I'm going to say that we are going to let z equal a. Now things are going to get quite cramped here if I continue working down in this corner. So let's move to another page. And on this page, I'm saying, let z equal a. Now, from the previous page, we have this equation this negative 9 plus 9z equals negative 9y plus 9z equals negative 9. I'm going to use that equation, so I'm going to pull that over to the other page. Okay, so using this equation from the previous page, now I have agreed, I've said we're going to let z equal a, so I know what that z is. Therefore, I can find y. So it's going to be negative y plus 9, and it's z is next. And I said we're going to let z equal a, is equal to negative 9. So y, negative 9y is equal to negative 9 minus 9a, and then dividing by negative 9, I'm going to have y is equal to 1 plus a when I simplify that. Think about what we're trying to do. Let's remember that. Back here, we are trying to find the solution to this system. And what has that meant to us up to this point? Or in any other problem that you've seen, that means when we're finding the solution to a 3-variable system, we're looking for the x, y, z coordinates that satisfy all 3 of these equations. What is happening here? Let's go ahead and talk about this right now. What is happening here is that our 3 planes are intersecting up on a line. So remember, a 3-variable equation is a plane, and I've got 3 of those in this case. And those 3 planes are intersecting on a line. So the solution to this system, when we think about it visually, is this line. So there are infinite points. There are infinite x, y, z coordinates that satisfy this system of equations. What we've done here is we've said the way that we're going to express these x, y, z coordinates is by letting z equal a. So I've got the z coordinate, and then I found y. I said y is equal to 1 plus a. So I've got the y coordinate. Now I'm going to find x. And to find x, I need to use one of the original equations. So going back to the previous page, I can choose any of the 3 original equations. I think I'll just choose the second one here. I think since the coefficients are the lowest, maybe that's the one I want to use. Here is the equation. If you look down in the bottom left, that's the equation from the original 3 that I've chosen, and I'm going to substitute into that equation the x and y that I've already got and find x. I mean the y and z that I've already got and find x. X plus 2, now we have agreed, if you look up to the right, that y is 1 plus a. I'm going to substitute that for y. And z, we said at the outset, is equal to a. And from here, I'm going to solve for x. 2 plus 2a minus a equals 5. X is equal to this 2a minus a is a, and I'm going to subtract that. So I will have a negative a on the right side. And then this 2 here, I'm going to subtract from the 5 so that I'll have positive 3. So solving for x here, I get negative a plus 3. Negative a plus 3. And let's just be clear on what this solution means in the context of the problem that we have been looking at. If I were to say, okay, I'm going to take this situation, I want to look at this situation where a is equal to 1. And then I take that and I substitute that 1 back up here. What would I get? I would get negative 1 plus 3 is 2, 1 plus 1 is 2, and 1. So that was just taking this a and putting it there, and there, and there, and then I get these 3 coordinates. these three coordinates, 2, 2, 1, these will satisfy any of these three equations. And the thing is, I could do this for any value, any real number value that I pick for A. I could say let A equal pi if I wanted to. And then I'd get negative pi plus 3 for the x coordinate, 1 plus pi for the y coordinate, and then I would have pi for the z coordinate. And if I take that point and I substitute it in here, it will satisfy the equation. Just trust me, or you can try it. So this is probably new to many of you, maybe a little bit difficult to grasp, but so you may need to look for some other resources or ask for some tutoring on it, or maybe work through a couple of examples before you get to help you get a handle on it.